Just to be safe. This single sentence drives more engineering decisions than most calculations. Whenever something feels uncertain, whenever performance isn't clear, this phrase quietly enters the discussion. And once it does, oversizing usually follows. Oversize the motor, oversize the pump, oversize the heater. The logic sounds simple. More capacity means more margin. More margin should mean more safety. On paper, that feels reasonable. But real systems don't behave like spreadsheets. Here's the unfiltered truth. Oversizing hides problems. It doesn't fix them. Instead of understanding the system, oversizing avoids the question entirely. Oversized equipment rarely operates at its design point. It runs at part load. It relies on throttling. It cycles on and off. Efficiency drops, and energy is wasted continuously. Nothing looks broken, but performance is quietly compromised. Bigger systems are also harder to control. They respond aggressively. They overshoot targets. They hunt around set points. Control systems struggle, not because they're poorly designed, but because the equipment is too large for the job. Oversizing also accelerates wear. Thermal stress increases, vibration levels rise, seals and bearings wear faster. Ironically, equipment sized for safety often has a shorter operating life. This shows up clearly in real installations. Systems that look safe on paper end up with higher failure rates on site. Not because they were under-designed, but because they were misunderstood. Real safety doesn't come from excess capacity. It comes from understanding variability. How loads change, how duty cycles behave, how environment affects operation. Safety is knowing the system, not blindly increasing margins. So the correct approach is simple. Understand the system first, design for real operating conditions. And only then, size the equipment. Just to be safe is not engineering. Understanding the system is. Subscribe to Engineering Unfiltered for real engineering, no filters.